Hello, I am Patel Mohit Kumar, enrollment number 2307020603025, and this is Patel Umang Vinod Bai, enrollment number 2307020603030, and Patel Kaksh Vijay Bai, enrollment number 2307020603022. We are studying in Bhagwan Mahavir University, BAIT, and have created a microprocessor and interfacing project on the topic of Arduino Uno R3 ping pong game under the guidance of Professor Rahul Gonawala. Introduction of report. This report details the circuit design and components of the ping pong game on Arduino, a schematic created using Tinkercad. The project, dated May 20th, 2025, spans 2 sheets and outlines an electronic system centered around an Arduino microcontroller. This report will provide a comprehensive overview of the components, their functions, and their interconnections as depicted in the schematic. Project objectives. Design and build a 2-player ping pong game. Utilize an Arduino Uno to control game logic and component interactions. Display the game on an LCD screen. Implement user input using push buttons. Incorporate sound effects using a piezo buzzer. Provide visual feedback using LEDs. Specifications. Arduino Uno R3 USB connector. USB-B pins. Built-in LED, pin 13 digital I/O pins, 14 analog inputs, 6 pins PWM, 6 pins communication UART, yes I2C, yes SPI, yes power I/O voltage, 5 volts input voltage nominal, 7 to 12 volts, DC current per I/O pin, 20 milliamps power supply connector, barrel plug clock speed, main processor 80MB 328P, 16 MHz USB serial, processor 80MB 16U2, 16 MHz, memory 8MB 328P, 2 KB, SRAM 32 KB flash, 1 KB EEPROM. Implementation, software requirements. You will need a web browser, internet, Tinkercad, in web working correctly. The source code is already provided here. Code explanation. Libraries and definitions. This section initializes necessary libraries for the LCD display and NeoPixel LEDs and defines the specific Arduino pins connected to various game components like push buttons and the piezo buzzer. Global variables. Key global variables are declared to manage the game state. These include arrays to represent the positions of the paddles and the ball on the character-based LCD screen. Variables for ball movement, X bounce direction, player scores, score 1, score 2, and a Boolean flag game to indicate if the game is active. Setup. Function. This function performs initial setup when the Arduino starts. It initializes the NeoPixel LED strips, configures the push button pins as inputs and the piezo buzzer pin as an output, and displays a splash screen with game instructions on the LCD. Loop. Function. This is the main game loop that continuously runs. Game. Start sequence. It waits for the start button to be pressed, sets initial paddle and ball positions, and initiates a countdown before the game begins. Paddle movement. It continuously monitors the state of the player input buttons to move player 1 and player 2 paddles up or down accordingly. LCD display update. The function updates the LCD to reflect the current scores and the real-time positions of the paddles and the ball using custom characters. Ball collision and game logic. It detects if the ball collides with either paddle, reversing the ball's direction, incrementing the corresponding player's score, and playing a sound effect. If the ball misses a paddle, the game ends. A winner is declared, LEDs flash, scores reset, and the game restarts after a brief delay. Ball movement. This part controls the ball's horizontal and vertical trajectory, simulating realistic bouncing off the top and bottom edges of the screen. Helper functions. Several dedicated functions manage specific game mechanics piezo sound entity. This function generates a short sound using the piezo buzzer for a specified duration. Conclusion. This Arduino ping pong game showcases the capability of microcontrollers to create engaging and interactive experiences. By integrating electronic components like an LCD, push buttons, a piezo buzzer, and LEDs, the project successfully replicates the classic ping pong game. The Arduino Uno effectively manages game logic, user input, and output, demonstrating its versatility in handling real-time interactions. This project serves as a practical example of how microcontrollers can be employed in embedded systems for gaming and other interactive applications. Thank you.